Hello once again, fellow Unity devs. Apologies for the delay in videos as I was away on holiday, but I'm back now so the videos should continue as before. And you also may notice that I upgraded my voice, so hopefully the quality of the tutorials improves somewhat. I don't think I'll be recording the voice for previous videos since I'd like to keep on going with new content, new tutorials. But anyway, let's jump right into making episode 9 of a bullet hell game in Unity. We last left off with our enemies spawning, but you'll notice that they just collide on previously set boundaries instead of despawning. Secondly, our projectiles don't despawn when they should. And thirdly, our world boundaries don't accommodate for various screen sizes. So let's get to it and address these things in this episode. So we need to have some kind of way to put our colliders on the edge of the screen that will prevent our players from escaping, no matter whatever the screen size is. So firstly, for the 4 box colliders we have under walls here, we can reset all of their values. We can edit multiple objects in Unity by left-clicking the top one and shift-clicking the last one. And we can just edit their values as normal. So let's make all of the scales to be 1, so we'll change this to 1 in the X and 1 in the Y. And the same for the box collider 2D size down here. We'll change that to 1 and that to 1 also. So let's add a layer for these 4 colliders, and we can go layer, add layer. We'll call this one block player and projectiles. Okay, and we'll go back and select all of our objects again, and we can set our layers on multiple objects in the same way that we change the values. Okay, so we'll want to create a script on our walls component, so we'll go add component, and we'll call this screen boundary controller. So let's go into that. Okay, so at the top here we're going to want references to our 4 walls. So we'll go public game object top, bottom, left, and right. And we can actually declare multiple variables if they're the same type, exactly like this. So in our start method, what we can do is we can access the screen width using screen.width and screen height using screen.height. So just like we used the camera function to get the mouse position on the screen to a world point, we can do the exact same thing with the width and height of our screen. So let's go and write vector3 screen to world max equals camera dot main dot screen to world point. And as our vector3 position, we'll pass in a new vector3. And here we'll pass in screen.width, screen.height, and we'll pass in the distance from our camera to 0, so this will be 14. Okay, next I'm going to explain a small bit of maths using my friend MS Paint. Okay, so we passed in the screen width and height, and we got it back as a world point in our Unity game. So let's call this point X and Y, and this is going to be the maximum height and width of our screen. And we also know another point, which is the center of our level, which is 0, 0. So from these 2 points, we can actually figure out all of the other points just by using some simple calculations. So the vertical points will all be 0 in their X. So this is going to be 0 and this is going to be 0. And the horizontal middle points will all be 0 in the Y. So the second value here will be 0 and the second value here will be 0. And for our second parameter here, we know that this is going to be positive Y, since this is the maximum height. And for our bottom one here, this is going to be minus Y, since this is the maximum negative height. And it's same for our X, so this is going to be minus X, and this is going to be positive X. And from here, we know that the entire length of our game world will be 2Y, and we know that the entire width of our game world will be 2X. So from this knowledge, we can actually calculate how high each collider needs to be and also their position. So let's go ahead and make some space here for a new variable called vector3 horizontal scale. And this is going to be equal to a new vector3, and we'll pass in our screen to world max dot x multiplied by 2, since it's 2x for our width. And we'll go 1 and 1. And we'll just copy that down. We'll rename this to vertical scale. And the difference will be that for our y value, it's going to be screen to world max.y multiplied by 2, and our x value will be 1. Okay, so we have our positions from screen to world max, and we have our scales from our scales here. Let's go ahead and actually apply these settings to our colliders. So let's start off with the top one. We'll go top.transform.position equals new vector 2. And we know, since that's at the top, that our x is going to be 0 and that our y is going to be screen to world max.y. And for its scale, it's going to be top.transform.local scale equals horizontal scale. And let's copy this for our bottom, with the difference being that it's going to be now in the negative y, and the scale will remain the same. And let's change this to the bottom. Let's copy it over once more for our left. We'll change the bottom to be left. Now the difference here is going to be that the x position is going to be a minus screen to world max.x, and the y is going to be 0, and the scale will be a vertical scale. So let's copy that over one more time and change that to right. Of course, this will be in the positive screen to world max.x, and the scale will remain the same. Okay, so let's go back into our Unity editor, and we'll assign the game object variables to our screen boundary controller. So we'll go top to top, bottom to bottom, left to left, and right to right. And let's see what happens. Okay, so we can see that it actually works, but because of the width of our colliders, it looks pretty weird when our car bounces off this invisible wall. So let's go back and fix this with an offset. So what we can do is we can create a new float called offset, and let's make this equal to 1. So for everything's position, we can go ahead and bring it apart by 1 unit. So let's add our offset to all of the positions. So for our top, it's going to be plus offset. For our bottom, it's going to be minus offset. For our left, it's going to be minus offset in the x. And for our right, it's going to be plus offset in the x. So since we brought everything back by 1, now there's going to be gaps in the corners. So what we have to do is we have to increase our vertical and horizontal scale by this same offset too. So let's add some brackets around our screen to world max variables here before they get multiplied. And let's add one to these. So we'll do that for x, and we'll do the exact same for our y. So now if we were to test this, our car wouldn't hit off some invisible wall on the screen. It'll be off the screen and the sizes will be correct. So that's our walls and positions done. Now another thing that we want to do is we need to be able to despawn our projectiles. So we'll need to register collisions between our bullets and our walls. So let's go back into our Unity editor here. Now, since neither projectile nor our walls have rigid bodies, which we do need to have at least one of to register a collision, we'll want to add a rigid body 2D to all of these walls. So let's go ahead and do that now. We'll select all of them. We'll add component rigid body 2D. And we'll change the body type from dynamic to kinematic. So what this means is that they will not be able to move, they'll be stationary. Now while we're here, we actually want to go into our physics 2D. So we'll go project settings, physics 2D. And since we want our enemies to be able to pass through these layers into what will eventually add triggers so that they despawn, we want to disable these walls from blocking the enemy. So we'll go and we'll untick the collisions between enemy and block player and projectiles. Okay, so next on our 4 projectiles, we'll select them and we'll add a new script, and we'll call this one projectile despawn. So let's open this up. We can get rid of the start and update functions here, and all we need is a on trigger enter 2D. So since we know that layer 9 or 11 is our enemies or players' bullets, what we can do is if we detect layer 9 or 11, we can despawn these layers. So we can go if collision.gameObject.layer equals 9, or, and we'll copy this bit over, if the layer is equal to 11, we'll go ahead and we'll destroy the collision.gameObject. So that's the player and projectile wall setup. So the player is going to be blocked by these walls, and projectiles will be despawned when they hit these walls. And now for our final thing. In this game, when an enemy spawns at the top and travels downwards, we want him to despawn. And it's the same when he spawns at the bottom and travels up, we want him to despawn there as well. So if you want to get 100% on this level, you'll want to destroy all enemies before they get off the screen, which is a challenge in itself. So let's go ahead and make 2 new game objects and walls. So let's make 2 new game objects in the walls. We'll go create empty. We'll call this one enemy despawn top. Now we'll duplicate that and call this enemy despawn bottom. Now we'll add 2 box colliders. So we'll add 2 box collider 2Ds, and we'll check the is trigger checkbox. So we'll have to go back into our screen boundary controller here, and we'll add 2 new references to enemy despawn left top and enemy despawn bottom. So what we'll want to do here is we'll want to set the top wall's transform and scale to be the same as our enemy despawn top. So what we'll do is we'll make some space down here and we'll go enemy despawn top dot transform dot position equals top dot transform dot position, and we'll go enemy despawn top dot transform dot local scale equals top dot transform dot local scale, and we'll copy these 2 over. And instead of enemy despawn top, we'll use enemy despawn bottom, and instead of top here, we'll use bottom. Okay, so let's go back into our Unity editor here, and we'll let our script compile, and then we'll add our enemy despawn top to the top wall here, and enemy despawn bottom to the bottom here. So next, we'll want to create a new layer, so we'll go add a layer, and we'll call this one despawn enemy. And we'll set these 2 walls that we just created to be that layer. So finally, let's go into our bullet hell enemy script, and we'll go into our onTriggerEnter function here, and we'll just add an else if. So firstly, we'll want to check if the object that we're colliding with is on the enemy despawn layer. So we'll go collision.gameObject.layer equals 13. So here what we want to do is if our wall is at the top and our enemy's direction is up, we'll want to despawn him because he's after reaching the end of his journey. And if our wall is at the bottom and our enemy's direction is down, we'll also despawn him. So this will prevent enemies from despawning as soon as they spawn, and it also allows us to have this mechanic of despawning enemies when they travel off the screen. So let's sort that in. So for our top wall, we'll go if collision.transform.position.y is greater than 0, so this means that it's above the center point, and the direction of our car equals direction.up. This means that we should despawn our car, so we'll go destroy this .game object, and we'll copy this over here into an else if. We'll just add a little else there, and we'll go if our position.y is less than 0 and direction is direction.down. So this means that the collision has happened below our center point and the direction of the car is down, so we should also destroy it. Okay, so let's go back into our game and see what happens. So we'll notice that all of our walls are being set to the correct sizes, and we have our 2 triggers here which are copying the size of our top and bottom. Then you'll also notice that we have our projectiles which actually despawn when they hit our walls now, and if we let this game run long enough, you'll see that the enemies will actually despawn when they reach the end of their travel. So in this tutorial, we looked at setting our screen boundaries so that our game will work no matter the screen size, and we looked at despawning projectiles and despawning enemies when they finish their moveset. So thanks for watching, and I'll see you next time.